How do harmonics damage power factor correction equipment? Imagine your electrical system as a busy highway. When everything runs smoothly, cars move at the right speed. But when there are sudden bursts or irregular traffic, problems can happen. That's similar to what happens with harmonics in power systems. Harmonics are voltage and current waveforms at multiples of the main frequency, usually 50 or 60 Hz. They are generated by devices like variable frequency drives, rectifiers, and electronic ballasts. These nonlinear loads produce distorted waveforms that can cause trouble for power systems and equipment. Power factor correction equipment, often made up of capacitor banks, is used to improve the power factor. The goal is to reduce the load on the electrical supply by supplying reactive power locally. But these capacitors are designed to work at the fundamental frequency. When harmonics are present, they cause several issues. First, harmonic currents flow through the capacitors and other components, leading to extra heating. This heating is caused by the equivalent series resistance in capacitors and the winding resistance in inductors. Over time, this heat can damage the insulation inside capacitors, making them less reliable and shortening their lifespan. Second, harmonics can cause resonance conditions in the system. When the system's inductance and capacitance combine at certain harmonic frequencies, they create resonant circuits. If this resonance happens near a harmonic frequency, it can amplify the harmonic currents and voltages. This amplification can lead to overvoltages and overcurrents that damage the capacitors or cause protective devices to trip unnecessarily. These resonance conditions can also cause the system to operate inefficiently, wasting energy and increasing costs. Third, harmonic distortion affects how power factor is measured. Since harmonics distort the current waveform, the measured power factor may not accurately reflect the true power quality. This can cause the control systems that switch capacitors on or off to operate improperly. As a result, the power factor correction may become less effective, or worse, cause additional problems. Finally, high harmonic currents can cause physical damage. Capacitors can fail prematurely due to dielectric breakdown, and protective devices like fuses or circuit breakers may trip more often. Repeated stress from harmonic currents reduces the overall reliability of power factor correction equipment. To prevent these issues, engineers use special measures. Detuned capacitor banks include series reactors that shift the resonant frequency away from harmonic frequencies. Installing harmonic filters, either passive tuned filters or active filters, can reduce harmonic distortion. Conducting harmonic analysis before installing correction equipment helps in choosing the right size and type of capacitors and filters. Larger neutral conductors are also used to handle triplet harmonics, which are multiples of the third harmonic, to prevent neutral overheating. In summary, harmonics damage power factor correction equipment by causing overheating, resonance, increased losses, and early failure. Managing harmonics properly with filters and system design is key to keeping power systems running smoothly and efficiently. Proper planning and equipment selection ensure long-lasting and reliable power factor correction in power generation and transmission systems.